All right, so thank you for taking my survey. I got a lot of your responses back. And so it sounded like most people wanted to do some things reviewing Unit 7. And I have an idea in the works for possibly letting you retake it. It's going to be in a not traditional way. And I just have to run it by Mr. Holden first. But if he says it's okay, then I can explain that to you more tomorrow. But I wanted to kind of kill two birds with one stone because the problems I picked today are from Unit 7, and there were things that I asked you to do on your previous test, but there are also things that are SAT review as well. So I tried to maybe do that, and then once we review the things that are SAT like on Unit 7, we can maybe move to some other review topics, like maybe some things from geometry since you haven't had that for a while. So I just have two examples to do today, and both of them have to do with a linear system. So remember, linear systems would be two lines. And so what could happen with two lines is they can intersect and they can have an ordered pair, XY, that is a solution. Or it is possible that, I'm going to try to move this over a little bit here. It's also possible that the system, if it has the same slopes, because they're lines, and different y-intercepts, that they would not intersect, so they'd have no solutions. And it's also possible that, I'm going to draw with two different colors, we have two different forms of the line, so we call that the same line or coincident lines. And the number of solutions to this is infinitely many number of solutions. So the first question is a multiple choice question for you to use without your calculator. Which of the following ordered pairs XY is the solution to the system below? Keep in mind, like on your test, sometimes the question's worded this way. Sometimes the question might ask you to find, like, hey, what's x plus y? I think on your previous test, I asked you to find x minus y. If you're going to notice over here, I ask you to divide answers. So often we ask you to do something with your solution, but this one's pretty straightforward. I'm just asking you to find x, y. And so the best way to do that is, in my opinion, to use elimination, which means I'm going to try to eliminate either the x's or the y's. It does not matter which variable you eliminate, especially in this case, since I'm going to need to find both x and y. What I am going to choose to do, because this is already negative and this is already positive, is I am going to multiply this top equation by 2. And so now what I have is 2x plus 2y, and 2 times 0 is still 0. 3x minus 2y equals 10. When I add these two equations, what this allows me to do then is eliminate the y's, because 2y minus plus a negative 2y is 0. So I get 5x equals 10, x equals 2. All right, now, if you're looking at your choices, what you're going to notice is if x equals 2, really there's only one solution that remains. Because the x value is the first value, b is the only one that has a solution of 2. So you could stop at this point. Let me just verify for you, though, that the y value is negative 2. If we would put 2 back in this equation, we would get 2 plus y equals 0, and the only way that that would be true is if y were a negative 2. So x is 2, let's be careful, x is 2, y is negative 2. The correct answer to this is letter B. Okay, above I mentioned some special solutions. Maybe you can see this a little bit more. Special solutions just means that something different happens. So we don't have the two lines meeting in an ordered pair. The two things that will happen with lines, we'll talk about nonlinear systems another day, is that either they won't meet or they meet all the time. So if they meet all the time, that means they're the exact same line. If they don't meet, that means that they have the same slope but different y-intercepts. In a system, when the lines are coincident, if you do elimination, you're going to get the variables to drop out and you're going to get a true statement, meaning you're going to get something like 10 equals 10. Well, no matter what you put in for x and y, what this is saying is there's going to be a true statement. So there are an infinite number of x's and y's. In this case where there's no solution, you would see an untrue statement. So something like 0 equals 5. The variables drop out. 0 will never equal 5. Therefore, there is going to be no x or y that will make that true. The second example is one where there is an infinite number of solutions. So in the system of equations below, a and b are constant, so that just means they're numbers. If the system has infinitely many solutions, what is the value of a and b? And so if you wanted to answer this correctly, what you need to understand is to have infinitely many solutions. These have to be the same exact line. All right, looking at this, then, what would a and b have to be exactly the same as the line below? And be careful. You might think at first, well, a has to be 2 and b has to be 8. Not true. If they're the exact same line, this number also has to match that. So we would need to first multiply the top row by 5. This gives us 5ax plus 5by equals 60. Now these match. All right, let's figure out what a and b are. So it looks like 5a equals 2, which means a is 2/5. It looks like 5b equals 8. That means b, is 8/5. You're asked to find the ratio of a to b, so a divided by b is 2/5 divided by 8/5. We all know that dividing fractions is the same as multiplying by a reciprocal. So this is 2/5. Keep, change, flip. So 5/8. And this is 2/8, which you could reduce to 1/4. Okay, so there are 2 SAT Unit 7 review problems. I've given you 2 problems to practice on the Google Doc, and you can submit your answer the same way as you have before with a photo.